Right, Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning to all of you. We are privileged this morning to continue and look at the first compound of chlorine, which is hydrogen chloride. That is going to introduce us to hydrochloric acid, and after hydrochloric acid, we shall be closing this chapter. So we have some good time today to discuss the chemistry of hydrogen chloride and hydrochloric acid, and we see the way forward. In a major setting, ladies and gentlemen, number one, we must identify the reagents required to prepare hydrogen chloride gas. We must be in position to understand and identify the conditions that must be fulfilled in order for the reaction to take place. We must be in position to state the method of drying. We must identify the drying agent. And as usual, we have questions to answer when it comes to a choice of a drying agent. We must be in a position to state the method of collection and give a reason as to why. Ladies and gentlemen, we must come up with the equation for the reaction, and we must conclude with a labeled diagram. This is where the content lies, and from this content you can think of producing an essay. You can think of producing an essay. So, from the notes, from what we have read, from what we have researched, what are our reagents required in order to prepare hydrogen chloride gas? We shall need sodium chloride. We can also use potassium chloride. We can use any chloride other than lead 2 chloride and silver chloride only. So brackets, let us think of any chloride that is soluble except lead 2 chloride and silver chloride. Why those two chlorides? Those two chlorides are insoluble. So let's not imagine sodium chloride all the time, sodium chloride all the time. In the event, the question does not use sodium chloride, students go back and use sodium chloride. It becomes wrong content, and you don't get anything. So what else shall we need? We shall need concentrated sulfuric acid. Now, I think you are capable of seeing as to why, we may not use this. I can include one. There is also barium what? Barium chloride will not be used. Why don't you use these three chlorides? Lead 2 chloride, silver chloride, and barium chloride. We don't use these three because of sulfuric acid. It ends up forming lead sulfate, silver sulfate, barium sulfate, and stops the reaction from further taking place. So you wait to see the gas, you don't collect the gas. Conditions for the reaction. This reaction requires that the acid must be concentrated because it's covered here. So acid must be concentrated. If you use dilute, you never get the gas. This reaction is going to take place at room temperature. No heating is required. Heating is not required. We are through with that. What are our drying agents here? There are many drying agents. Number one, you remember there is calcium oxide, but it is basic. There is calcium chloride, it is neutral. There is sulfuric acid, it is acidic. So you have to choose from the three. And the best drying agent here is concentrated sulfuric acid. What does it suggest? That this gas should be having the same properties as sulfuric acid. Hydrogen chloride, we get hydrochloric acid. So it means the reason here is acid versus acidic. No reaction. Can we try calcium oxide? No. Why? Calcium oxide is basic. The gas is acidic. A chemical reaction. So in my usual style, in my studio right now, I have two people. One is acidic, the other is basic. I can't leave them in the studio. That is out. I will be responsible because I find when I've reacted. So I don't want to answer those questions. It's the same thing here. So why don't you use calcium oxide? Because calcium oxide is basic, therefore it will react. So what shall we end up with? Calcium chloride. No gas involved. The name of the product is calcium chloride. The name of the studio will be something else. So, method of collection. How do we collect hydrogen chloride? It's collected by downward delivery. If not, it's called upward displacement of air. As you come down, you displace air upwards. So the reason must be available. The gas is heavier, denser than air. Equation. We can think of the equation here. The equation is, for example, sodium chloride is a solid. We are adding concentrated sulfuric acid, which is a liquid. So what is the product? The product is going to be sodium, hydrogen, sulfate. I can accept a solid. Though I may not take, here I can accept liquid and accept aqueous. But here I'll strictly accept what? Solid. So what else will be formed? Hydrogen chloride, which is a gas. Why do we avoid dilute sulfuric acid? Dilute sulfuric acid has water in it. And there is no, you can bring water near hydrogen chloride gas, as we shall see. That's why I am insisting that the acid must be concentrated, and to be safe, use L to stand for acid without any moisture in it. When you keep this acid in air for a long time, maybe for 2 days, even if it's concentrated and use it, it doesn't give you the gas readily. So that is it. So before I go into the logistics of the diagram, what type of gas is this? From my usual classification of gases, we said generate and collect. We have been talking about generate, dry and collect, generate, purify, dry and collect. When do we generate and collect? If you don't want the gas that is not dry. So here the gas is not dry. And therefore, how do we collect such gases? Over what? Water. But can I risk hydrogen chloride with water? No. Because of its nature, it is not a GC gas. I am now left with a GDC and a GPDC. Of the two, one of them is going to be chosen. So which of the two will be taken up? In your own opinion, think about it. I'll tell you whether you are right or wrong. Wherever you are, think about which of these two methods shall we employ. And I'm giving you 20 seconds. Then I'll get the answer from those in the studio, and therefore we shall compare. GDC. Those in the studio are saying GDC. Generate, dry, and collect. Why not generate, purify, dry, and collect? Purification requires what? Water. And this gas and the water cannot be separated. So the method is GDC. You can figure out a diagram without a teacher right now. How many setups are there? 3 setups. Generation setup. What does it contain? A flask, a thistle, funnel, and a delivery tube. What about the drying chamber? Awash, bottle, delivery, tubes, and sulfuric acid. What about collection point? Gas jar and delivery tube. You can connect the three and come up with a diagram without a teacher. And I'll task you to find out if you can draw this diagram alone, because from this information, you are going to generate an essay. With a diagram, without a diagram, and a diagram only. How many questions are there on gases? 3. And most likely this could be our last things to be looking at. 3 questions on gases. So figure out how should your diagram look like. How should your diagram look like? So what is remaining here to have my table complete is test for the gas. By the test for the gas, we shall look at it at the end, having figured out how the diagram should look like. So quickly begin to sketch your diagram somewhere. Don't look at what is in the book. Make a sketch somewhere on a rough piece of paper and see if it's going to be a right sketch or a wrong sketch. And I'm giving each one of us 2 minutes to sketch and label. 2 minutes. So I'm clearing this information on the whiteboard. 2 minutes, sketch and label. Two minutes, sketch and label. Sketch and label. The bigger the diagram, the more difficult it is to draw. You can draw using a pen, you can draw using a pencil. This is chemistry. But when labeling, don't use a pencil. Use strictly a pen to label. I'm calling upon you to remember the rules governing diagrams. So 1 minute is over. Think of the second one. Make a rough sketch. You'll make it better later on. Because I'm about to make 1, 2, and we compare. I have started. Don't look at mine. Draw yours, and we shall compare notes later. My diagram may be wrong, so don't copy mine. We shall agree later whether it is right or it is a wrong diagram. So no checking. My diagram is also wrong until you prove me right, and I'll prove you right. As for now, even if you are 2 in a room, 3, your neighbor's diagram is wrong until further notice. So the 2 minutes are over for you. I'm also concluding on mine. So, each one of us check if your diagram looks like, more or less like the one on the whiteboard. You check. If yours is different, then there is something wrong. So, this is the G point, generation point. This is the drying point. This is the collection point. Make sure there is no gas leakage completely. If your diagram looks like that, I expect you to label for me this. I expect you to label this. We should have labeled this one, and we need to label that one only. So, what do we need to write here? Whoever has written conc is wrong. I want the word in full, concentrated. Sulfuric acid. Don't use formula, don't use symbols to label diagrams. So this should be my sodium chloride. This is again our concentrated sulfuric acid. And this is our hydrogen chloride gas. So where are the points of evaluation? The points of evaluation are lying under concentrated sulfuric acid. The word concentrated must be there in order to score that point. This is sodium chloride. This is concentrated sulfuric acid. Dilute is wrong. Sulfuric acid just silent. You will not be appreciated. This is hydrogen chloride gas. And if your setup can work without causing a problem, without failing you, WA, working apparatus, 1 mark. If you have drawn a round bottomed flask, I repeat, I expect it to be clamped. If you have drawn a conical flask, it is okay. If you have drawn a flat bottomed flask, it is okay. If you have drawn a beaker, it is okay, as long as you can cork it. So this is the type of setup. Working apparatus, 1 mark. Now if you look at this diagram, what type of question do you think is it answering? The diagram, the way it has been drawn and has been labeled, what do you think is the question? So the question in this diagram is answering right now is the question that says, with the aid of a well labeled what? Diagram, comma, describe how a dry sample of hydrogen chloride gas is prepared in the laboratory. The way the diagram has been labeled answers this type of question. So what is the standard answer? We have drawn, we have labeled, we now talk. Two things are expected: the diagram and the explanation. With the aid of a diagram, draw and explain. So what is the explanation? Our standard essay always says sodium chloride is put in the flask because it is a solid. Statement number 1, complete. Statement number 2, concentrated sulfuric acid is poured down into the flask through the thistle funnel because it is a liquid. Finished. Statement number 3, the gas is passed through concentrated sulfuric acid to dry it because It does not react with the acid, since it is also acidic. Step number 3, the last one, sentence number 4. The gas is collected by downward delivery because it is denser, or rather heavier than air. What will follow next? The equation that we wrote. And the diagram is there. 8 marks. So if the diagram has taken 3 marks, the essay is taking 4 marks to 5 marks to give a total of 8. Addressing issues of concern only. Are we there? So this question is enough for this diagram. Our second question always says, describe, I am editing mine. For me, I'm like I can edit. My second question is saying, question sample question number 2. Describe, I'm removing that first statement. So I'm converting this into a capital D. So the question reads, describe how a dry sample of hydrogen chloride gas is prepared in the laboratory. What follows next? Brackets. Diagram is not what? Required. Diagram is not required. They are stopping you from drawing and labeling a diagram. So what is our usual style? The hint has always been, where they say diagram is not required, what do? Put the diagram in words. Talk about the diagram in sentences that a blind person like me, I can draw a diagram in my head. So imagine you are blind, but you must see the diagram in your head. Can you see a diagram? No, unless somebody talks about it, then you can visualize and see how possibly this human being is looking like, is what is expected. So since they have refused the diagram, it is not my problem. So what are we going to do? That's the diagram. I said, please don't draw and don't label. I'm now covering the diagram. So what are my expectations? Is for you to draw me a diagram in my mind so that I can see how the setup is looking like. So what do? The question is more demanding and carries more marks. All the 8 marks will go for that essay now. Which means the 3 marks will appear in a diagram but given to apparatus. So what do? Supposing you're told to set up this apparatus and the video, what do you begin with? You will begin with this one. Isn't it? Alright? So you begin with this one. So this is my flask. This is my flask. The first thing to do is to pick sodium chloride, which is a solid, and put it inside here. So what will I do? Sodium chloride is put in the flask because it is a solid. What follows next? You bring the stopper. This stopper has a delivery tube and has a thistle funnel. So the flask is fitted with a stopper, having a delivery tube and a thistle funnel as the second step, which is missing in the original essay. So that one takes some of the marks around. Alright? So what you do next? The mixture, the reaction takes place at room temperature. Alright? No, before that, fit the flask with the cup having a thistle funnel and a delivery tube. You can talk about the diagram and complete. You can bring the diagram in phases. What I like most is to bring the diagram in phases. So concentrated sulfuric acid is poured down into the flask through the thistle funnel because it is a liquid. So there is a new sentence in between. Using a delivery tube, the gas is passed through concentrated sulfuric acid, which is in a wash bottle. So a wash bottle is a marking point. Delivery tube is a marking point. Wash bottle is a marking point. Thistle funnel is a marking point. You did not talk about them in the first question because we are seeing them. So why do you pass the gas through the acid? To be dried, because it does not react since the gas is also acidic. Finished. How do I move from here to here? Using another delivery tube. The gas is collected in the gas jar. So the gas jar becomes another marking point with the reasons that we already know. Because the gas is heavier than air. So there is no diagram, but we have talked about it in words. That's what we mean by drawing the diagram in words. It is okay, you can say sodium chloride is put in the flask because it's a solid. The flask is fitted with a thistle funnel and a cork and a delivery tube, which is then connected to a wash bottle, and the wash bottle using a delivery tube is connected to a gas jar. You are right. Then you get back to the usual essay that we have been having. Reaction takes place at room temperature. The has concentrated sulfuric acid dries the gas because of A, B, C, D, and so on. Whichever format you think of is good for you, it is okay, as long as the connection of the apparatus is reflected in your essay. We may not have time to go back look into these issues, but we must have the content. If we have an opportunity, these things will again come back in the last maybe month towards final examinations in the form of seminars and discussions, so that I will come back and again throw more light on these issues. So that is that. Third question. I am editing this question completely. So what is our third question? Our third question is now saying, draw a well-labeled diagram of apparatus that can be used, or that is used to prepare and collect a dry sample of hydrogen chloride gas. Allow me to use the abbreviation here, but it's not allowed. So have they told to explain? No. They are just told to draw and label a diagram. Very well. No explanation. What have we been saying? You draw a talking diagram. So put all the information on the diagram. I'm therefore saying this is concentrated sulfuric acid, which is at what? Room temperature. You have seen there is an additional piece of information. This is solid sodium chloride, or sodium chloride what? Crystals. Crystals are not liquids. Additional information. So what is this? Concentrated sulfuric acid. Why? To dry the gas. Since it is also acidic and does not what? React. Write the information. To dry the gas, because it does not react. Bracket, I can even say gas is also what? Acidic. Communicate. So what is this? Dry hydrogen chloride gas collected by downward delivery. Even if you don't label gas jar, even if you don't label delivery tube, even if you don't label wash bottle, even if you don't say this is a thistle funnel, this is a flask. For me, I want this type of students who will label even this apparatus, because you don't know who is going to decide how the game is going to be played. Sometimes you change the rules of the game to see those who really know what they are doing or not. Supposing there is a bonus mark for those who have labeled apparatus. And some of these conditions come in depending on how students have answered the questions. If you suspect there is cheating, you look for extraordinary students to take certain marks, those who know what they are doing. And for me, I want students whose answers are not supposed to be debated. You don't give a mark out of judgment. And I think, no, for me there is no thinking. The answer is the answer. You make the game harder, you still go through. They make it lighter, you sail through. So if there is one marker for labeling apparatus, then you might miss it. Because you don't have authority over who is going to give what and where. The rules will be determined before the game of marking begins. So that is it. So when I push for some of the things here now, I'm pushing for them because I know my students are going to come up with them in their essay. So you push for them. And you insist on them. Then when they say, hey, so it is right. You get it. People say, hey, it is right. It's right. It is right. Hey, we have seen them. School X has done that. Exactly like that. That kind of thing. So it is to prepare you to be better players than other students. Okay. So one student is saying, why don't you use dilute sulfuric acid? I mentioned that we don't use dilute sulfuric acid because dilute sulfuric acid has water in it. And because of that water, the hydrogen chloride gas is going to be produced ends up dissolving in it. So you never collect hydrogen chloride gas. It doesn't produce hydrogen chloride gas because of the water, since the gas is very soluble in water. Right? So that's one question so far. So this is it. I'm therefore through with preparation of hydrogen chloride gas using the three types of questions that can be asked. At this moment in time, let us head for that test. How do you know that the gas is hydrogen chloride? Prove that your gas is hydrogen chloride. Prove that your gas is hydrogen chloride. How do you prove that your gas is hydrogen chloride? There are two tests. Test number one. You bring a jar of ammonia gas. A jar of ammonia gas near hydrogen chloride gas. This was done in senior 1 to demonstrate diffusion. So, if this is what you have done, observation. What do you see? You see dense, thick, white fumes. Conclusion. The moment you see the white fumes, you conclude that actually the gas is hydrogen chloride. There is a chemical equation. Ammonia as a gas is alkaline plus hydrogen chloride a gas which is what? Acidic. the two automatically, immediately react with one another to form a compound called ammonium chloride. Ammonium chloride is a compound seen as white fumes, very tiny particles that are suspended in air. The equation for formation of, we wrote it. The equation for formation of hydrogen chloride was written. But if at all you missed it, we said sodium chloride, a solid, plus sulfuric acid, a liquid, gave us, it doesn't give sodium sulfate, it gives sodium hydrogen sulfate, a solid, plus hydrogen chloride, a gas. This was given at the beginning of the submission. That's why I did not write it again, but it was given. If you missed it, please recapture it. So, ammonium chloride is what is seen as white fumes, the way you see dust. Dust is a solid. So these particles are very tiny and they are light, that they remain suspended in the air. After some time, they settle. Therefore, the equation is ammonia is NH3, a gas, plus hydrogen chloride, also a gas. What do we see as dense white fumes? It is what is called ammonium chloride. So it appears as a gas, but we will finally settle as solid particles. So you see solid particles of ammonium chloride, light enough to be suspended in air. This one proves that a gas is hydrogen chloride. We do this qualitatively during the practicals. If you are preparing hydrogen chloride or preparing ammonia in the lab qualitative analysis practical, we test using ammonia. If the gas being prepared is hydrogen chloride, we test if the gas being prepared is ammonia using concentrated hydrochloric acid. It produces hydrogen chloride gas, and these two form white fumes. Senior 1, probably either second term or first term when you are looking at diffusion. All right. I'm taking on some question. For what? There are people who are not even going. Okay, let us continue. Those are asked for the notes, you'll help them. So this is what is happening. This is test number 1. Allow me continue to look at test number 2. In test number 2, we pass. If not, you bubble hydrogen chloride gas through silver nitrate solution. And this is part of your quantitative analysis. So what will happen? Silver nitrate solution reacts with hydrogen chloride gas. We obtain a compound called silver chloride. And from your chemistry of senior 2, you know what silver chloride is, an insoluble substance. Then the hydrogen ions will react with nitric ions to form nitric acid. And the nitric acid. So this will be the products of formation. So what's the color of silver nitrate? From your qualitative analysis practicals, it is colorless. So hydrogen chloride are white fumes, light, not dense. What's the color of silver chloride? It's white. And remember, it is insoluble, therefore it is a solid. So what's the color of nitric acid? Colorless. So what is our equation, therefore? When you bubble bubble hydrogen chloride through silver nitrate solution. Hydrogen chloride is a gas plus silver nitrate, that is a solution. What do we obtain? Silver chloride, which is a solid. So the hydrogen and the nitrate is going to give us nitric acid. This is aqueous. So what do we see? An observation is we see a white precipitate. Wherever there is a chloride and there is a silver ion, we get insoluble salt. Silver nitrate is what is expected. So these two serve as the chemical tests for hydrogen chloride gas. I am now capable of saying that my students can now fill this table and complete it. They can talk about a gas now, then think of the reagents, then feel about the conditions, you think of purifying, then we think of drying, we think of collection, we can think of the test, and finally think of the equation. So in this topic alone, our gas was chlorine. What were the reagents in chlorine? There were quite many. We had manganese 4 oxide. We had hydrochloric what? Acid. What were the conditions? The acid must be concentrated. So concentrated acid, and requires the process of what? Heating. Purification for chlorine. Did we need to purify chlorine here? No. If you purify chlorine, yes, from concentrate, because concentrated acid gives fumes, white fumes. So it is possible we needed water to remove acid what? Fumes. Drying was concentrated sulfuric acid. Reasons we know. Method of collection was downward delivery. How do we test for chlorine? What are the chemical tests for chlorine? Its reaction with litmus. It can also be its reaction again with ammonia. It also gives dense white what? Fumes. So we can use litmus, it's bleached. You can also use what? Ammonia. Remember we said chlorine removes any hydrogen. So what do we end up with? White fumes of hydrogen chloride. And nitrogen is left behind. That was one aspect. Equation you can write. The essay you can now produce. Diagram you can draw. What type of gas is this? Type of gas? GPDC. If not, we use the potassium permanganate. And the same hydrochloric what? Acid. What were the conditions? We insisted on concentrated what? Acid. And this reaction took place at room temperature. So purification, yes, as above. Drying, as above. Method of collection, as above. Test, as above. The equation changes. Are we there? Now, we are introducing. I have answered the question of dilute acid because the dilute acid has water. All the hydrogen chloride dissolves in the water, doesn't come out. What about the ionic equation? Now, ionic equation preparation of hydrogen chloride, we are using concentrated sulfuric acid. Concentrated sulfuric acid does not ionize. Sodium chloride may not ionize. Therefore, we don't have an ionic equation for preparation of hydrogen chloride from sulfuric acid. And acid only ionizes when it is in solution and is dilute. So let's look at hydrogen chloride gas. Reagents, sodium chloride. What else do we need? Sulfuric acid. The acid must be concentrated acid. Reaction takes place at room temperature. Purification not required. Why? The hydrogen chloride is very soluble in water. That's why I don't use a dilute what? Acid. Can we dry? Yes. Concentrated sulfuric acid. Same reasons. Method of collection? Yes. Same reasons. What about the test? You test either using concentrated ammonia and gives white what? Fumes, or test using silver what? Nitrate and gives a white what? Precipitate. Equations you can write. So how many gases have we covered so far? Hydrogen, I expect to be in your table now. Oxygen must be there. Nitrogen must be there. Carbon dioxide must be there. Ammonia must be there. Carbon monoxide must be there. Chlorine must be there. Hydrogen chloride must be there. Which gas haven't you covered here as a school? Have you covered sulfur dioxide? Is the only gas that is left, so that this table is a complete table as for now. So this is what we have as for now with this summary. So the people in the studio, any question? Right. So properties of hydrogen chloride gas. Number one, there are things you already know. This gas is acidic. And because it's acidic, it turns blue litmus to red. You have seen this gas is very highly. It is highly, or it is extremely, whichever term you want to use, or it is very soluble in water. Very soluble in water. Like ammonia, actually it's the second to ammonia in terms of solubility. Which means you can also talk about the fountain what? Experiment here. Method of collection is a heavy gas. So it's the gas that is denser or heavier than air. Simple physical properties. Actually it appears as white fumes, but not dense. The one with ammonia becomes more thick, like a thick cloud, not a light one. So white fumes, but yet they become dense. So these are a few physical properties. Now when it comes to chemical properties, I'll wait and push them to hydrochloric acid that I'll mention. So there are a few chemical properties you can look at here. Big and acidic gas, very soluble in water. What does it produce? Hydrochloric acid. And therefore, what is hydrogen chloride? Hydrogen chloride gas is what produces hydrochloric acid. It is hydrochloric acid without water. So let me demonstrate its acidic nature due to high solubility, so that its effect can be felt on blue litmus paper. I am therefore saying hydrogen chloride as a gas, very soluble, plus, if you say plus water, the equation must be different. If I say hydrogen chloride plus water, what do I obtain? The other side. I cannot say I'm getting hydrochloric acid aqueous. What happens? The equation becomes incomplete and unbalanced. So neither can I also write plus water this way. We don't repeat. So what is expected? If I want to write this equation, I will say hydrogen chloride gas. And therefore, I'll put water on the arrow. It now changes to hydrochloric what? Acid. That is aqueous. However, if you want to add water, the equation becomes hydrogen chloride, a gas, plus water. The equation changes into something else. This is a liquid. So what does it give us? It's going to give us hydrochloric acid is going to be written in style. It's going to be written in style. So this one plus this one is going to give us a compound that we call H3O plus aqueous plus chloride ions, aqueous. Here water has been taken in. So the hydrogen chloride donates a hydrogen ion to water to form what we call a hydrozonium ion. This is called hydrozonium ion. Actually, an acid is a substance which when dissolved in water produces hydrozonium ions. That you call hydrogen ions in water. So these are hydrogen ions in water. This equation is heavy. So you either go with this one. If not, you say HCl gas plus aqueous. Where aqueous means what? Water. So what do you obtain? HCl aqueous. So these and these are good for you. This is very correct, but mostly it is the A-level students who may be required to use it. But if you come across and you write it, it's a very correct equation. Because an acid is something that can donate a hydrogen ion. So donate to who? This donates to water. So what is an acid? A substance which when dissolved in water, when dissolves in water produces hydrogen ions. The hydrogen ions are actually what? Hydrozonium ions. That we call hydrogen ions in solution. So it is not an acid until it has formed hydrozonium ions. Sulfuric acid concentrate is not an acid because in this concentrated form does it have hydrozonium ions. Until you put what? Water. Question. I am testing for nitric acid. If you are testing for nitric acid, can I use silver nitrate and hydrogen chloride? Somebody is testing for nitric acid. You want to use silver nitrate and what? And hydrogen chloride. If you are testing for nitric acid, you don't use silver nitrate and hydrogen and hydrochloric what? Acid or hydrogen. It's not possible. To test for nitric acid, you use, for example, calcium carbonate. It will give you bubbles of a colorless gas because of the hydrogen ions. To test for nitrate ion, you shall see them when you are covering the chemistry of nitrogen, which you have covered. Here we use the freshly prepared iron to sulfate, the brown ring test. So it is not possible. You cannot test for nitric acid using silver nitrate and hydrochloric acid. However, if you are testing for chloride ions in hydrochloric acid, you are right to use the two. Maybe it's the phrasing of the question. So if you are testing for chloride ions from hydrogen chloride, you will use silver nitrate and nitric acid. Acidified silver nitrate. You will see a white what? Precipitate. If it's a gas, then that gas must be hydrogen chloride. But anything that has chloride ions will show a positive test. But most of them are not gases. They are solids. But if it's a gas, then that gas is strictly hydrogen chloride gas. So your question has been inverted. It's the other way around. We test for hydrogen chloride using acidified silver nitrate. And any other compound that has a chloride ion in it will give us the same positive test. Mutas is saying, what is the smell of hydrogen chloride gas? It has an irritating smell. How many gases have irritating smells? Sulfur dioxide, ammonia, there is chlorine, hydrogen chloride. So any test that is not good irritates. There is choking is different. When you smell a gas and you cough, it chokes you, is different. So this one, any other gas that you have ever heard of, they have mostly what we call irritating smell. As if you feel itching, not pleasant to smell. So there are so many gases that have irritating smells. What happens in chemistry practical? We don't expect you to smell gases unless we direct you to do so, because most of them are poisonous. Purpose of answering questions in paper 2, we don't ask questions about physical properties. We ask questions about chemical properties. Because physical properties help us in the lab to identify a compound that is being investigated. Teacher, pardon on the equation you have written.
Third equation.
Yeah, the equation. You can see the third equation is beginning to bother people. That's why I'm saying it is a complicated equation. You go for simple ones. This one is a simple. HCl plus aqueous gives aqueous hydrochloric what? Acid. But this is the cheapest. If this one is disturbing you, you leave it. Because when you add hydrogen chloride to water, it dissolves in what form? Hydrochloric acid. If you write it like this, let me repeat. If you write that HCl plus water, and you give it just as hydrochloric acid, aqueous, you are correct. But the equation is not balanced. Here we have H, there is H, there is Cl, there is Cl, we have H2, there is O, here they are missing. So it becomes an unbalanced what? Equation. So that's why I say instead of adding water, you rather put water on the arrow. The moment you put water on the arrow, we don't balance equations using what appears on the arrow. You are safe. So you either write it like this or write it like that. The moment you want to write it like this, then it must be the other one. Because this one now donates, this hydrogen is donated to water. So hydrogens become 3 and 1 oxygen with a positive charge. This is what we call a hydrozonium ion, plus now a chloride ion. So this is what we are calling hydrochloric what? Acid. What is an acid? A substance which when dissolved in water donates hydrogen ions. What is a donation? You give out. Somebody must what? Receive. So who has received? Water. When water receives that proton, hydrogen ion becomes a hydrozonium ion. From your definition of an acid, which when it dissolved in water donates hydrogen ions. It donates the hydrogen ions to water and the water becomes hydrozonium ions. Let me illustrate. If I'm looking at sulfuric acid plus water, this is what happens. So sulfuric acid plus water, when it becomes dilute, it actually exists as H3O, and there are 2 of them. So we need 2 water molecules. This is plus a sulfate. This is what we call sulfuric acid in a solution. I don't want to go into this chemistry. Let's remain with this one and that one. In case you write this one, then you have chosen to swim in deeper water. A respective metal what? Chloride. Plus hydrogen gas. Being an acidic gas. But what does it call for? It calls for passing this gas over the metal must be what? A heated what metal? So all the chemistry summarized. All the chemistry now is summarized. Senior 2 chemistry, what did we say? Metals react with the acids to form metal salts and hydrogen, sodium chloride and hydrogen gas, zinc chloride and hydrogen gas. What about iron? Now iron does not give iron 3 chloride. It gives iron 2 chloride because hydrogen chloride is not a powerful oxidizing agent. Therefore, that is something worth it to note. That for iron, what do we form? We form iron 2 chloride, not iron 3 chloride. So when do we get iron 3 chloride? When you use what? Chlorine. In the previous lesson. Now we might say, first equation you have written is questionable. aqueous. What would the
What would the examiner ask you? Never put it. Because he thinks there are many aqueous solutions.
The other one, she's questioning the word aqueous. That the phrasing. So when I say hydrogen chloride gas plus aqueous, in chemistry when you say aqueous, the word means water. Sodium chloride aqueous means sodium chloride in water. So chemistry when you see the word plus aqueous, it means you are adding what? Water. Now it tends to become aqueous. So thank you for that. So that one is okay. So for iron, we form iron 2, but not iron what? 3. So from senior 2 chemistry, that one has been handled. We can figure out equations. And right. Do you expect hydrogen chloride to react with alkalis? Yes, obviously. Like sodium what? Hydroxide. Acidic, basic. Obviously. Here I can't put two people of opposite characteristics together and live with them. Whether you like it or not, they will react. You may not react today, but tomorrow, maybe the next day. You are joking. So what will be the product here? This neutralization. So what do we get here? Sodium what? Chloride plus water. What did you say? Acids react with alkalis to form salts and water only. Senior 2 chemistry. So if it's potassium hydroxide, potassium chloride. Calcium hydroxide, calcium chloride. Magnesium hydroxide, magnesium chloride. So HCl gas plus magnesium hydroxide aqueous. In water, what do we obtain? Magnesium chloride plus water. 2 hydrogens. Here there are how many? Chlorines are 2. Here chlorine is 1. These are 2. Oh, 2. This is 1. So like how you style, that is a 2. Hydrogens have changed to how many? 4. So there must be a 2 here because oxygens are 2. Balanced equation. This is aqueous in water, and so on. Do I expect hydrogen chloride to react with silver nitrate? It was one of the tests. So what do we form? Silver chloride plus nitric acid. So, generally, the reactions of hydrogen chloride gas are the same reactions of hydrochloric acid. It reacts in its way, gaseous form with metals when the metals are heated. But the rest of the compounds, as long as they have water in it, this one straight away changes to hydrochloric what? Acid. So it means that you and I have the responsibility of preparing now nitric acid. So it's hydrochloric what? Acid. And from hydrochloric acid, the lesson seems to be over. Topic seems to be over because we have looked at properties of acids in senior 2 with the carbonates. Do I expect hydrogen chloride gas to react with, say, calcium carbonate? With the sodium carbonate?
No.
Why not?
Because
if it is dry, it may not. But if it is wet, damp, moist, wherever there is little moisture, what does it form? Hydrochloric acid. So what do you expect? Calcium, chloride, carbon dioxide, and water. So being acidic, expect to react with metals, metal oxides, metal hydroxides, metal carbonates, metal hydrogen carbonates, and a big hydrogen chloride with the silver nitrate to form a white precipitate. So these are our expectations. We are now left with preparation of hydrochloric what? Acid. How do we do it? So that we convert this gas into hydrochloric acid. And the same properties will again come back under hydrochloric acid. All of them, the way you see them, they're coming back. That's why we spend a little time on this one. So what are the uses of hydrogen chloride gas? Preparation of hydrochloric acid as one of the important uses of hydrogen chloride gas. So, let me see. We still have, I was told 5 minutes, but we still have to noon. We still have 15 minutes, though we started early. So let us see, unless the system is going to log us out. So let us go into hydrochloric what? Acid. This one is now HCl acid. Where do we prepare it from? We shall prepare it from hydrogen chloride gas. I'm not going to do again a setup, but if I want, I can do a setup and prepare it in the lab. So what happens is, from our diagram, I have hydrogen chloride gas coming in from the source. To this hydrogen chloride gas coming in, I connect it to an inverted funnel. So this one is a connector. So this is dry hydrogen chloride coming in from our previous experiment. So connect to an inverted funnel. Put this funnel into a beaker that is having water, but make sure that the rim of the funnel just touches the surface of water. So since this gas is very soluble in water, the gas will come. The gas comes down. Then it reaches the surface of water like this. It quickly, very fast, spreads and dissolves since the gas is very soluble in water. What was originally water now becomes hydrochloric acid, which is the same as H3O plus Cl. This is what we are calling hydrochloric acid. This is what we are calling hydrochloric acid. So this is how hydrochloric acid is prepared. There is nothing very complicated. The moment you don't use a funnel whose rim is touching the surface, if I bring this test tube and I just lower the test tube inside the water like this, something funny is going to happen. All this water is going to be sucked back immediately, back to the source where the gas is coming from. So we use a funnel to reduce, to minimize sucking back. Either use a delivery tube. The moment the first gas comes here like this, since there is high competition, the water rushes in to go and look for the source. Where is the gas coming from? So the purpose of using a funnel is to equalize pressure so that water does not rush back into the flask where the gas is coming from. Remember, in the gas flask there is concentrated sulfuric acid. The moment the water jumps into the acid like this, the glass breaks, explodes. And remember, if sulfuric acid gets spilled onto you, then you have stories to tell in the future what happened to you. So that's why we use an inverted what? Funnel. So what's the purpose of using the inverted funnel? To avoid the process of sucking back of the water into the source of the hydrogen chloride gas. So there is nothing complicated here. So if you put litmus here, what will happen? Litmus will turn from blue to red. If you put silver nitrate, you will see a white what? Precipitate. If you put here sodium carbonate, you will begin to see bubbles of a colorless gas. If you put a metal, you will begin to see bubbles of a colorless gas. What does it mean? Hydrochloric acid has been produced and hydrochloric acid is reacting. So they are the same properties. So if we are looking at now hydrochloric acid, so hydrogen chloride in water is producing hydrochloric, but this time it is aqueous, originally from gas. Originally from gas. I also said hydrogen chloride gas plus water, but you write aqueous, you obtain HCl aqueous. However, hydrogen chloride plus water, you get hydrozonium ions plus chloride ions. The combination of two is what we are calling hydrochloric what? Acid. So what are properties of hydrochloric acid? Senior 2 chemistry. Being an acid, so HCl being an acid, it reacts with, again back to the summary, number 1, metals. Check if there's any question. It reacts with the metals. So predict what is formed. Number 2, it reacts with metal oxides. What do we form? Number 3, it reacts with metal hydroxides. This is salt preparation in the senior 2. What do we form? It reacts with metal carbonates. This time there is no heating, it's an acid. So it also reacts with metal hydrogen carbonates. Metal hydrogen carbonates. So what do we form with the metals? We shall form a metal chloride and hydrogen gas. What do we form here? Metal chloride and what? Water. What do we form here? Metal chloride and water. What do we form here? Metal chloride, carbon dioxide, and water. It's the same thing here. It's the same thing here. Properties of hydrochloric acid. Not every metal will react. So which metal shall we leave out? Lead and silver. So lead silver, lead silver, lead silver, lead oxide, no. Lead hydroxide, no reaction. Lead carbonate, no reaction. That kind of thing, because it's insoluble salt. So the equations you have been writing, and you have them in the senior too. So we don't go so much into the details of those. So additional information here is now reaction of hydrochloric acid with, again, silver what? Nitrate. So what shall we form? This time it is HCl aqueous. So we shall form silver chloride plus nitric what? Acid. Aqueous, this is a solid. White precipitate. It's a special reaction for hydrochloric acid to prove that it has chloride ions, and any of this proves that it has got hydrogen ions. So if I ask, describe how hydrochloric acid can be tested for in the lab. Hydrochloric acid. How many tests do you talk about? Hydrochloric acid can be tested for. 2. Number 1. You can look at reacting. Now, metals might be more difficult. So you pick any of these metal carbonates. But you are right. So what do you see? Bubbles of a colorless gas. Which gas is carbon dioxide? What does it prove? It proves that it has hydrogen ions as an acid. Then for this one, silver what? Nitrate. It will give a white precipitate of silver chloride, isn't it? Showing that it has chloride ions. So it gives us a combination of the two. You look at the cation and the anion. But it could be tested using ammonia. White fumes of ammonium chloride. So these are the scenarios that we are supposed to be having. So briefly, the senior 2 work summarizes the properties of hydrochloric what? Acid. So are there uses of hydrochloric acid? Any uses? Yeah. It had. It was studied, but now they have said at noon. That's why I was still and I started quite early. But it's okay. So let me conclude. Let me now conclude. Because we started early, we are benefited, and one thing to help me to wind up. So uses of hydrochloric acid, you can read about them. So what is left now are compounds of hydrochloric acid, chlorides, isn't it? So do you know soluble chlorides? All chlorides are soluble except lead to chloride and silver chloride. How do I prepare those two? By precipitation. All chlorides are soluble. Qualitative analysis for chloride ions. How we test for chloride ions in the lab? We use, first of all, lead to nitrate. It gives a white precipitate. And we confirm using silver nitrate. And it gives a white precipitate. So as for now, we shall stop at this moment, read it through. In my next interaction, probably I will be bringing a chloride so that we carry out simple experiments on chlorides for qualitative analysis as a reminder, because I know maybe people have forgotten a bit and so on. But by the time you left, we had gone a little bit far. So thank you so much for attending the lesson. Continue to work very hard. Time is not on our side, but things have to continue. Thank you so much. Good afternoon and Assalamu alaikum. You left, we had gone a little bit far. So thank you so much for attending the lesson. Continue to work very hard. Time is not on